Alrighty, it's been about 45 minutes since I started assembly. 45 minutes ago, all I had was a hole in the ground. I put a metal casing down there so that I could just drop the pole in, and that way I can reposition this as I wish, left or right. So we have the two panel arrays up here. It's morning time, so they're facing kind of to the east, and they're both at 70 degrees right now. That's at their full elevation angle. So let me show you how this thing works. Get my little 12-volt battery here, 11.7 volts. I got two actuators. This one is my vertical actuator, and if I put 12 volts on it like this, you'll see the array tilt for the wintertime position. Right now it's in the summertime position, and you can see it moving. So that's the elevation control, and you can see what I have here. I have a bolt going through to the inside, and that bolt is being driven by this actuator, and we're just about stopped. 1, 2, 3. Right there. Now, the way I did this was I cut a slot in the outer tube, and the inner tube has a bolt going through it. I have a nut on the back side of the inner bolt welded, and I also welded a sleeve so that the bolt is supported on both ends. If you can see that, the bolt goes through and it has a sleeve on the right and a nut on the left. So that's the elevation angle, and right now we're probably about 75 degrees vertical, 15 degrees off of vertical. So that's the wintertime position. Now, I have this set up loosely, but I can still control it. Now, if I wanted to change this setting for the azimuth bearing, all I got to do is hit the actuator, and this actuator starts to move, and it turns the whole array. I'll just stand here and you can watch it move. So this is going to have about 120 degrees of throw. To actually follow the sun at this latitude, I need about 220 degrees of rotation. I don't have that. I didn't choose to do that. I'll explain that after I finish getting this to turn. Right now this is dead south, and you can see the actuator arm here. The rod doesn't move, but the barrel is, and that's because the barrel is working on this lever arm over here, which is welded to the drum, and coming up to the end point here very shortly. You can watch this right in the middle here. Okay, and that's all the way to the limit, which is far east as I'm going to get. Now, I have to reposition this the way I want it, but this actuator is basically a slot cut out, and it's about 120, 130 degrees here. I could actually extend it more if I wanted to, shorten up the lever arm here, and get more throw out of this. But at this point, I'm going to leave it where it's at. So I got about 45 degrees of elevation control, about 130 degrees of azimuth control. Some of the features are this bar here. Gotta get so I see my hand. This bar here has two saddles. I made the saddles on the array holders so that this would be very simple. And then the saddles just sit on here, and they're held down with two benign simple hose clamps, one here and one there. The hose clamps just help hold it, but it's pretty steady. I also have a hose clamp closer into the center barrel. This hose clamp here keeps the shaft from moving even a little bit, because the bearing down here hits the edge of this hose clamp and won't go left or right. There's one on the right, there's one on the left. These bearings are full floating. As you can see, the shaft has up and down play. These bearings are free to rotate, and what they do is they allow self-alignment. So that's the array, and after I decide where I want it, I can kick it further west or east, whatever I want. Right now, you can see my sun It's right about here. It's up in the trees. And in the wintertime, it's going to be under the trees. So I'm not going to favor winter that much. I'll probably leave this thing so I can rotate it by hand and get the course positioning. So that's how we did it. These are all 1-inch square aluminum channel, which I welded or tigged together. And these are panels, if you look at them, all nice and square, 70 degrees angle on each one. So that's the way we have it. So that's the vertical actuator. As you can see from the side, it moves this bolt up and down, which turns this drum inside of the main sleeve. This sleeve is welded to this sleeve. This sleeve rotates on the main shaft. The shaft doesn't rotate. This assembly turns back and forth under control of my azimuth control. So that's how it goes together. From putting the pole on the ground this morning to having it operational here was about 45 minutes. I had everything planned out. A lot of drafting, a lot of design. Now the panels that I have here are coming up and coming out. And these panels will lay down in this bed here. They have back supports and they're going to sit inside this channel. And I'm going to run a couple of screws, stainless, through the channel to secure the panel in this frame. And that way I'll have two panels, one above the other vertically. And that should work out pretty good. We're behind the house. Prevailing wind is from my left or from the house, which is north. And as a result, this should be in fairly safe weather environment. So that's the project for this week. Coronavirus has stricken me in many ways. I am staying home and I just can't not do nothing. So this has taken about a week's worth of welding and cutting and prep to installation today. Today's Friday. I started on Sunday, so that's a pretty good thing. Now the panels here, where's my hand? The panels here were designed so that they'll be just about as tall as this pole here. And the reason is, for expansion, I can put two more panels here laying sideways, left to right, if I need to. Then that way I'll put a bracing strut across here and two panels vertical here and here. And then that way I can have 6 panels. I got 4 panels now at 120 watts, which is 480 total. So there you have it. And it's been fun. And we got a solar ham station for the heck of it. All driven by thermonuclear power from our local star. This is N4MQ. Enjoy. Have a good day.